Imagine this. The width of ancient horse carts may have influenced the size of rocket boosters used in modern space missions. It sounds ridiculous at first, but this story captures something very real about technological progress. The past quietly shapes the future. In engineering, early design decisions create long-lasting constraints. They influence infrastructure. Infrastructure influences future innovation, and this same pattern is unfolding right now in artificial intelligence. There's a famous engineering story. Ancient carts and chariots developed a standard wheel spacing. Roman roads developed ruts based on those wheels. Later, wagon builders kept similar spacing so carts could travel on those roads. Early railways adopted similar wheel spacing, and railway tunnels and infrastructure were built around those rails. When rocket components had to be transported by rail, their size was constrained by those same systems. Historians debate how accurate this chain is, but the core idea remains powerful. In engineering, we call this path dependence. Small decisions made early can shape technology for centuries. Infrastructure becomes a constraint, and constraints shape innovation. Artificial intelligence today is often portrayed as a sudden revolution, but the truth is very different. Most of the foundational ideas behind AI were developed decades ago. Neural networks date back to the 1940s, backpropagation was developed in the 1970s, and reinforcement learning emerged in the 1980s. For decades, these ideas existed mostly in research papers. The math existed, the theory existed, but the computing power did not. The real breakthrough in AI wasn't just new algorithms, it was infrastructure. Three things changed everything. First, GPUs originally designed for gaming turned out to be perfect for neural network training. Second, the internet created massive datasets of text, images, and video. And third, cloud computing made it possible to train models across thousands of machines. When these forces converged, AI models suddenly became capable of learning at massive scale, leading to the rise of large language models. Large language models changed the world almost overnight. They can write code, generate essays, explain complex concepts, and assist with research and engineering. These models learn patterns from enormous datasets. They don't just memorize information, they learn statistical relationships across language, and when scaled up with enough data and compute, their capabilities grow dramatically. But this leads to an important question. Are language models the final form of AI, or are they simply the first generation of scalable intelligence systems? Some researchers believe the next major leap in AI will come from world models. Instead of only predicting text, these systems would learn how the real world works. They would learn from video, images, and interactions, build internal simulations of environments, and predict outcomes before taking actions. Much like humans mentally simulate scenarios before making decisions, this kind of AI could power robots, autonomous systems, and scientific discovery, moving AI from language understanding toward real-world reasoning. The future of AI likely won't be a single model type. Instead, we may see hybrid systems, where language models handle reasoning and communication. World models understand physical environments, reinforcement learning systems plan actions, and multimodal systems combine vision, sound, and language. Together, these components could form something closer to general intelligence. And this brings us back to the original idea. Small decisions shape infrastructure, and infrastructure shapes the future. Ancient transportation standards may have influenced modern rockets. And today, large language models are driving the construction of enormous AI infrastructure, from GPU superclusters to global data pipelines and multimodal training systems. That infrastructure may eventually enable something far beyond text generation. In other words, large language models may not be the destination. They might simply be the railroads of artificial intelligence, and the real journey may just be beginning.